Sean over here. Sean right there. He's
All right.
Not the Fortish. Not the Fortish.
So here we go. We're going to talk about derivatives and tangents with polar equations. Okay. So dy dx. Okay, this is going to look very similar to parametrics, where we have to do the dy d theta over dx d theta. Yeah. What is x in polar form?
R cosine theta.
What is y?
Sine.
So when we go to find dy dx, we have to take dy d theta over dx d theta.
Ooh.
Let's talk about dy d theta. If I'm going to take the derivative of y equals r sine of theta, what would that look like? What rule do we have to do?
Chain.
We have to do the chain rule.
R can be like an F.
Well, that's going to be. You got that already. Substitute that in.
So sine. Okay, so this is what I'm going to do. We're going to call R f of theta. Okay. That way, when we take the derivatives, everything's going to be in terms of theta. Does that make sense? Because R, in order for this to work, R is going to have to be in terms of theta. Okay, so then we're all in the same variable. So if R is f of theta, then when we do the product rule, okay, we're going to have to take f prime of theta times sine theta plus f of theta times cosine theta.
Shouldn't there be a negative in there?
Where?
With the sine theta?
Why?
Because the derivative of cosine is negative.
We are working with dy d theta.
Oh, dy. Oh, okay. I messed that all up.
Okay. Now, if we work with dx d theta, we have f prime of theta times cosine of theta minus f of theta sine theta. Now, in my opinion, you would not have to memorize that, because you can do the chain rule, or excuse me, you can do the product rule. Okay, all that is the product rule. Okay, so what's happening is these are our conversions. Our conversion to x, we take r times sine of theta. Our conversion for y is, excuse me, r cosine theta. Our conversion for y, r sine theta. Okay, so you're going to write your conversion, and then you're going to take the derivative with respect to theta for each of them and make your fraction. Okay, you are not going to memorize this. I think that would be silly. Yes.
So if you plug in a theta value, so you get like a slope, is that going to be like an equation that kind of looks like a line that we want?
Yeah. Yeah. So it'll be the slope at that point.
But it'll be like a polar equation.
Well, since we're finding dy dx, we're finding it in terms of, I mean, it's going to be in terms of the xy plane.
Okay.
But like, we can put a polar curve and then draw an xy plane, right? and then we can imagine what that slope would look like at that point.
Yeah.
Are you with me?
Yeah.
Okay. So, let's remind ourselves, how would we find horizontal tangents?
Top is 0.
Okay, so in this case, what is the top?
F. Yeah. Okay.
So dy d theta is 0. What about vertical tangents? Okay, now there is one stipulation for both of these.
They can't equal each other.
You can't both equal 0 at the same point.
Okay, and what happens if both of them equal 0?
We
We
have,
aren't talking about limits.
yeah.
It is,
Yeah.
okay, it's not smooth. Okay, yes, you guys are imagining it correctly. So horizontal tangents, as long as dx d theta isn't equal to 0, and as long as dy d theta isn't equal to 0. All right. So here we go. Write the equation to the tangent line of the polar curve r equals 5 sine of theta at theta equals pi over 3. Now, in order to write the tangent line equation, I know that we have a polar curve, but we're going to have to write it in rectangular form. So, in order to find the slope of this tangent line that we need to write, we need dy dx. We're also going to eventually need the xy coordinate so we know where to put the tangent line. So the first thing, let's just go ahead and write what our x and y conversions are. X would be r cosine theta. So we have r cosine theta. And y would be r sine theta. So I'm going to write that. Is that okay? Yes, Mrs. Holman.
That's wonderful.
Thank you.
Yeah.
Okay. So let's go ahead and find dy dx. We'll start with dy d theta. Ten sine theta. Good. And then r dx d theta.
Oh no.
Negative 5 sine squared. Addition is commutative. I don't care how you write it.
Because like I usually do the jumping in the first one.
Yeah, I usually do too. I was just following what you told me. So now what do we need to do with this?
Plug it in.
Plug what in?
X and Y.
Okay, this is our slope, and we want our slope at theta is pi over 3. Okay, we just did the unit circle today and freaked out to this. Well, yesterday and today.
Oh, yeah. They've been complaining about it. Maybe someone. Mrs. Holman says we're going to have to use this every day. No, we're not.
Probably the one.
We did the unit circle walk where I made you go outside
Yes,
with the
I
chalk.
remember that.
Okay.
Did that like today?
But I can't do it with chalk though.
Did you make a snow circle?
She just makes a stick with being on the floor.
I took a bed sheet and I taped out the unit circle on a sheet, and so I laid it on the floor. Okay, back to calculus. What is the sine of pi over 3?
Yes.
Times the cosine over negative 5 times sine squared would be 3 halves plus.
3 over 4.
Thank you. times cosine squared would be 1/4. You have it? What do you have?
Yeah. Yeah.
Yeah.
Should be negative. Yeah.
Yeah.
Definitely negative?
I think it's definitely negative.
Definitely, I think.
Yes. Hey, yeah.
I definitely think
But
that.
30% of the time he's right every time.
Okay. So now this represents our
Slope.
slope. Now we need a
Point.
point.
Or you just plug it in.
Yes, so up here, x equals 5 sine theta cosine theta. So x is 5 times radical 3 over 2 times 1/2, which is? Yep. And then y is 5 times sine squared. So 15/4. So, our tangent line equation is y minus 15/4 equals negative radical 3 times x minus 5 radical 3. Done. So we're still talking about the same concept, but they just look a little different. Let's see if I can. Well, I don't need my graphing calculator. What's the graph that we're talking about here? 5 sine theta. And where is that?
It's going to be a circle, meaning up the diameter 5.
That was terrible.
I'm sorry. I'll try to tell you in the future. Thanks. Pretty great estimate.
Better?
Yeah, that's good.
So here, at pi over 3, our tangent line has a slope of negative radical 3.
Now I've got to convert that equation back around.
Yeah.
How do you do that? You just plug in
R sine theta, R cosine theta, solve for R. It will be very ugly.
Yeah, it's convert our rectangle.
Which is
It's
why.
like we learned like
For the
the
line, convert the
horizontal and vertical lines
Yeah.
for the polar stuff.
Yeah, the x, the,
R cosine theta equals A.
Yeah.
Vertical.
okay. Now I want to take r equals 1 minus cosine theta, and I want to find where this has horizontal and vertical tangents. Okay, first of all, what is this?
So it's going to be one of the hard ones.
It's cardioid.
Are you later?
yes.
The hard one.
How many eyes? 4?
So we have 3 horizontal lines.
2 vertical.
Okay,
Equals.
so let's see. First, let's work on horizontal, which means we're going to set what equal to 0. dy d theta. Okay, so let's go ahead and write down what y is. Y would be
Sine
r sine theta. That's one. R sine theta. Okay. This is where our solving of those trig equations the other day is really going to come in handy. So dy d theta equals. So derivative of the first would be positive sine
Yeah.
times sine plus the second times the derivative of the first. Second. So we are working with sine squared plus cosine minus cosine squared. And what do we want to do with this equation?
Zero.
Set it equal to 0. How will we do that?
Well, there's 2 squared, so it must equal 1.
If it was sine squared plus
Well,
cosine
we've got
squared, it would be
a sine
fabulous.
squared, and we can just like do a 1 minus cosine squared too.
Okay, since this is a cosine squared and this is a cosine, okay, we're going to want to change this also to cosine.
So we could have a perfect square.
Okay, so sine squared is the same as
1 minus cosine squared.
1 minus cosine squared plus cosine minus cosine squared. So what we are working with is 1 plus cosine of theta minus cosine squared of theta.
Shouldn't it be 2 cosine squared?
2. I meant 2. There's an invisible 2.
I saw it.
And a silent 2.
Okay.
Those are very tricky.
English.
By negative 2.
You want to divide by negative? I would not divide by negative 2. Because then you'd be working with fractions.
Let's divide by negative 1 then.
Are we completing the square?
Yeah.
You do not need to complete the square.
Oh,
Okay, that's not right.
We have a trinomial.
Oh.
And what can we do with trinomials?
Back.
Yes. So to get 2 cosine squared, we need 2 cosine times 1 cosine. To get negative 1, we need a positive 1 and a negative 1. Where should the negative 1 be?
Yeah.
So then cosine of theta equals 1.
So this means 2 cosine of theta plus 1 equals 0. Are you okay with me jumping straight to cosine of theta equals negative 1/2?
Yes.
And here cosine of theta equals 1. So where does that happen at? Where's cosine negative 1/2?
2 pi over 3, 4 pi over 3.
Where's cosine 1?
0 to 2 pi.
or
No.
0.
I'm gonna write. Okay, we'll write 2 pi, just to be safe. Because it does take us from 0 to 2 pi to draw the line. Alright, so that was all for horizontal. Now it is important that we look at vertical, just in case we have some overlap. It asks us to do both, but on the AP test, if they ask you where there are vertical tangents, you better check to make sure where there's horizontal in case there's any overlap you have to cross out. Okay? So let's talk about vertical tangents. which means we need to look at dx d theta. So let's write x. X equals r cosine theta. Right? So dx d theta. What?
Negative sine theta plus
So sine theta, cosine theta. Oh, you distributed before you took the derivative?
Yeah.
Okay.
I did it different.
I like this value.
Would that make it easier
I
if we
don't.
distribute it first?
It's not
I'm fine with that.
bad either.
Six one way, half a dozen another, right? It doesn't matter how we get there, we just gotta get there. You for the expression for me. Okay. So if we distribute first, it probably will make this easier. Because then there's no product rule, so we have negative sine theta minus 2 sine theta cosine theta.
Plus another negative in that last part. Yep.
So if we want to set this equal to 0,
Factor out the sine.
okay, since both of them have sign. Okay, please keep in mind, because some of you will be tempted to like move the negative sign over and divide by sign, so then, oh, cosine theta is 1. Don't do that. We can't divide by functions because they could be 0, and we can't divide by 0. Okay? So, factor out a sign. Left over, I'm going to write it as 2 cosine of theta minus 1. Does anybody have a problem with that? So we're looking for when the sine of theta is equal to 0, or when 2 cosine of theta minus 1 equals 0. So this happens at
So we got
0, pi, and 2 pi. Do you agree?
yes.
As well as
Pi over 3 and pi over 3.
okay. So where do we really have horizontal tangents?
Yes.
2 pi over 3 and 4 pi over 3. Where do we really have vertical tangents?
Pi over 3 and pi over 3. And pi.
Okay? We are not smooth at 0/2 pi. What's happening at 0/2 pi?
It's making the point of the heart where it comes
Okay,
together.
that's where the yeah.
It's what makes it a cardioid.
Okay, this was 1 minus cosine theta, correct?
I
Okay,
don't even know.
Yes, it was.
so that means the majority of it is on the
Right. Wait, left. Yeah, left, because it's minus. Okay. Yeah. Which means 4.
okay.
Early.
So here are our 2 horizontal tangents. Here are our 1, 2, 3 vertical tangents. That makes sense with that picture, doesn't it?
Yes.
Okay. Do you remember back in pre-calc when you really didn't know why we were solving trig equations? Here it is.
Okay, so why are we doing trigonometric calculus?
Well, because it's fun. The end goal of anything in math, apparently.
What?
Finding tangents.
Oh, yeah.
Ooh,
Well, this does
fun.
seem to go to calculus where the
Is
first
this entirely smooth?
Okay. If you have, okay, so if your R value is 0, that means we are at the pole. Okay. So, if your R value is 0, but not your derivative, but not the derivative of R, then the line theta equals alpha is tangent to the pole.
By whole sentence?
Yes.
We would
Yeah.
use.
Well, it could be like pi,
This is what you
pi,
back between
outside pi
R's.
or it could be,
Or after R.
Oh. yeah, it's supposed to be-
Tripping my brain.
No, the angles start straight up and down, like equal 0. You can find out. Plug it into your geometric graph and it's set.
Okay, so we have R equals 2 cosine of 3 theta. Okay. So I want to know where this crosses the pole, which means we find the zeros. How many zeros does this polar curve have?
1, 2, 3.
Cosine is equal to 1, so yeah, just 3.
Okay, it starts here because it's cosine. We have 1, 2, 3. So basically, it's where the cosine is 0, which is where? Okay, pi over 2 is the first place. 3 pi over 2, and then we need one more. Okay, so our zeros are at pi over 6, pi over 2, and 5 pi over 6. Okay, if you recall something I mentioned a couple days ago, when we draw petals with an odd number, it's only going to take us from 0 to pi to draw them. All right. Now, what this is saying is we have tangent lines of theta equals pi over 6. Theta equals pi over 2. And theta equals 5 pi over 6.
Hold on, so.
That makes perfect sense considering how zeros work. It seems obvious.
So it's a function of.
Well, right, but when we were talking about these polar curves in pre-calculus, you didn't know what tangent lines necessarily were, so now we can talk about them in calculus. Yes, it's obvious.
This is the language have to make it seem so much more complicated.
Yeah.
Isn't that just how math goes? The words are always more confusing than the words. We always have to bring that up.
Yes. What?
I didn't say
Pretty
this
much.
one.
Say what? Hospital?
Yeah, the code is simplified same, so it's not so
Okay.
scary.
Now these tangent lines are written in polar form. We could write them in rectangular.
That's cool.
Okay, so your homework, which I'll let you go ahead and begin, is on page 725. 59 and 65 to 75 on. On Monday, we will talk about polar area. And it's really cool.
Which means we're doing the trigonometric integral again, aren't we? Is this trigonometric integration?